So, in this portion we are going to understand how to capture the association between a numerical and a categorical variable. Here I am assuming my categorical variable has only two categories. In other words, if I am looking at gender, for example, it has two categories, a male and a female. I could have another variable which is say income. I could just look at two categories, which is just high category and low category. So, I am assuming my categorical variable has two categories, and this is referred to as a dichotomous variable. So, now we are going to see how we summarize the association or understand the association between a categorical variable and a numerical variable. Let us look at the following example. So, suppose a teacher was interested in knowing if female students performed better than the male students in her class. So, what did she collect? She collected data from 20 students. Now, these 20 students and the marks they obtained in the subject she is teaching on 100. A very small subset of the data set. So, you can see that there are 20 students. I will just show the data to you. So, I have the first student is a girl who has obtained 71 on 100. The second student is again a girl who has obtained 67 on 100. The sixth student is a male who has obtained 83 on 100. The 20th student is a male who has obtained 90 on 100. So, these are the marks of 20 students, and the data that is recorded is the gender. Now, gender is a categorical variable. Now, the levels of these categorical variables are two. The first level is a female, the second level is a male. It is nominal because there is no order in this categorical variable. Whereas, marks is a numerical variable, can take any value. Here I have seen that 71 out of 100, 67 out of 100, this is a numerical variable. Now, we are interested in understanding whether females perform better than males. So, we want to know what is the association between, first of all we are asking the question, is there an association between gender and the marks, or are they not associated with each other? We introduced a concept which is referred to as a point biserial correlation measure. So, let us start by looking at a scatter of this data. Okay. To look at a scatter of this data, what I first do is the following. I code my categorical variable. What do I mean by coding my categorical variable? I have gender female and male here. So, I am just coding it because now I am looking at whether I can quantify the correlation between these two variables. So, if I just write, for example, if I just try and see, I will put a correlation measure, okay, and you can see that it returns an error because it says that correlation has no valid input data. It has no valid input data because this is categorical and it is text. So, let me code this variable. So, this coding I am just arbitrarily choosing female as 1 and male as 0. So, you can see that this data is coded in the following form. So, here I have two data sets. This could be the data obtained in one test, and this could be the data, or this could be the marks obtained in of the same 20 people in one test, and this could be the marks obtained of the same 20 people in another test. Okay. So, let us first start with a scatter plot of this data. So, again I go and I plot a scatter plot. Okay. I do not want a line chart, I want a scatter plot. Okay. And within the scatter plot I am using my column D as labels, because column D is taking only 2 values, I am using column D as labels. Okay. And within this column D, again what I do is I go and I customize it further by looking at the major spacing type, which is step, and I am putting a step value of 1. Okay. So, you can see that I have constructed my scatter plot, in which I have my x. I again go back to my titles. The title is gender coded versus marks. My horizontal axis, I have gender. Okay. And on my vertical axis, I have marks out of 100. Okay. And the way I can interpret this scatter plot is, you can see that this 0 represents a male here and 1 represents a female here. So, you can see that whether it is male or female, all of them have obtained marks in the same range. So, the scatter plot tells us an important story here, and the story which this scatter plot tells us is, irrespective of gender, the distribution of marks seems to be the same, because both female and male seem to have performed equally well in a particular range. But now, let us look at the second data set. Okay. So, if I go back and change this data range, let me look at the data range taking, so it is F21 to F1 to G21, that is the second data range of my data. So, for this data range F1 to G21, now you see that there is some difference. What is the difference you notice here? You can see that 0 or the males are clustered in this region and females are clustered in this region, to indicate females have performed better, they have obtained higher marks than the males in general. Okay. So, you see that in the earlier case, so you can see that in the earlier case, that is in this case, the first case, I see that 1 is again female, 0 is a male, and you can see that the marks obtained are the same, whereas in the second case again I can see that females seem to have obtained higher marks than the males in general. This is the distribution of marks for males and the females. So, the question is, again here I do not have a line, I have just these points. Fitting a line for this kind of data is of no use to me. So, how do I summarize the strength of this association? For this we have a measure which we refer to as a point biserial correlation coefficient. So, let x be a numerical variable and y be a categorical variable. In our example, x is my marks, it is the numerical variable, y is the gender, which is the categorical variable. I am assuming a dichotomous variable, gender has 2 levels, again I have a level of female and male. How do I compute the point biserial correlation between these two variables? The first thing which we do is the following. We go back, you group the data into 2 sets based on the value of the dichotomous variable y. That is, I am saying y takes a value 0 or 1. Here in my example, I have assumed y takes the value if the gender is male and y takes the 1 if the gender is female, and that is how I have coded my data. So, you can go back and see that this is how we have coded the data here. So, if I have y, it takes the value 1 if it is a female and 0 if it is a male. Okay. Group the data into 2 sets based on the value. Okay. So, this data again I have, so this data I have 171, this is the same data. So, in this 2 sets I have two groups. What are the two groups? One is a female group and one is the male group. So, in the first step, in the second step, you calculate the mean values of the two groups. How do I do this? One way to do this is, I can just find out what are the total number of females. So, if I count the total number of females, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 females. So, out of 20, I have 12 females and 8 males. Okay. So, I have 8 males. So, my 0, this is my male. Okay. So, if I am summarizing it, males, I have 8 males and I have 12 female students. Okay. So, the proportion is nothing but 8 by 20, which is going to be 0.4, and 12 by 20, which is 0.6. Okay. So, that is how, and I am referring that to P0 and P1. Now, what is the next step? The second step says calculate the mean values of these two groups. So, how many females do I have? I have 12 females. What is the mean value? It is going to be 71. Okay, 71 plus 67 plus 65 plus, so forth. I can keep doing 91 plus 85 plus 69 plus 75 plus 79 plus 86 plus 75 plus 90 plus 91, which is 944. Okay. A simpler way to compute this is through using a sum if function. How do you use a sum if function will be taught in the tutorial. It is a simpler way, that is, if I have a female, I am just computing all those data points which correspond to the female. So, I can use what is called a sum if function. So, this 944 represents the total marks obtained by female students. Similarly, 658 is the total marks obtained by all men students or male students put together. Now, what is the mean of this group? I have 12 students in this group. So, the mean of this group, which is going to be nothing but 944 divided by 12, which is equal to 78.66. So, y1 bar is giving me the mean of the female group. What is the average mark of the female students? Similarly, the average mark of the male students is 82.25. Okay. So, if you go back to step 2, it is saying that compute y0 bar and y1 bar, which are the mean values of the group. So, y0 bar here is the mean of the group of male students, y1 bar is the mean of the group of female students. Then I can find out what is the proportion of observation. Again, I know that P0 is going to be 8 by 20, P1 equal to 12 by 20. This is the proportion of observations of the group which I am coding 0, and this is the group I am coding 1. Finally, Sx, x is my numerical, it is a single numerical variable which is the marks. Remember, when I have numerical variable, I can define what I call as standard deviation measure, which is telling me about the variability of that particular variable. So, Sx is the standard deviation of this variable. So, variable, entire variable, which is E2 to E21. Okay. Then the point biserial correlation measure is defined as yo bar minus y1 bar by Sx divided by P naught into P1. Certain books use a N naught and N1. N naught is the number of observations. Okay, so, P naught is basically N naught by total. If N is the total number of observations, and N naught is the number of observations in my 0th group, the group that is coded 0, N1 is the number of observations in the group that is coded 1, then N naught by N is equal to P naught, P1 is N1 by N. Okay. Some books or some authors, instead of looking at this as P naught into P1, use a sample correction, which is only this term is replaced by N naught by N minus 1 into N1 by N. Okay. So, you can see again this N minus 1, which keeps playing a role always when you talk about sample characteristics. So, this is how you compute a point biserial correlation coefficient of a data which has both numerical and categorical variable. So, for this data set, again going back, I have computed the point biserial coefficient, which is 0.188, and this for the next data set it is minus 0.96. Again, is there a difference between 0.188 and minus 0.188? See, this 0 and 1, I could have changed female to be 0 and male to be 1, then I would have got a different sign. Okay. That is what I have computed here. There is no, since there is no order, there is no hard and fast rule that female should be 1 and male should be 0. I could have changed the ordering. Okay. So, I could have changed the ordering to be, if it is female it is 0 and it is 1 here, otherwise. Okay. So, you can see that there is a flip in my, this one I have 12 males. So, now this would become a female because I had 12 females, sorry, this would become a female now. This would be a male. Okay, 8 out of 12. This has the standard deviation remains the same because I have not changed anything. My y naught bar now is going to be your E22 by D22, y1 bar is going to be 658 by 8. Okay. Now, you can see that the point biserial, which was earlier 0.188, is now minus 0.188. So, depending on what is your coding, you are going to get this point biserial correlation coefficient. That is the key difference between what I wanted you to observe between numerical data. I have a strong positive or a strong negative. Here it depends on how you are looking at the coding, and that decides on what is your point biserial correlation coefficient. Okay. So, whether it is a so here I can, so basically in absolute terms this would lie between 0 and 1, and it is closer to 0. It says that in this data set my gender really has no association with the marks. And that is sort of validated by my scatter plot also for my first example, which said that irrespective of which gender you are from, your marks seem to be distributed in the same way. Now, if you go to the second data set, which is this F and G columns, and do the same exercise for this data set. Okay. Let me revert to my earlier coding of female is does not make a difference, but I just wanted to revert to my earlier coding. Okay, and compute the point by serial. So, now again there are a couple of things which I want you to see here. You can see that the total marks obtained by females here is way high than the total marks obtained by males, whereas here it was 944, 658, here it is much higher. If you look at the group means, the means in the first example were close to each other. The total mean of the male group was about 82 and the female was about 78. In fact, males had a higher mean than the females here, whereas here you can see that the males are, the female mean is about close to 90, whereas the male mean is close to 70. There is a huge difference. Here there is not too much of a difference. The standard deviation is again not very different. This is 9.5 and 10.8. They are not very different from each other, but when you look at the point biserial correlation measure, this is very much close to 1. In fact, it is 0.963. Again, that is something which is validated here by saying that yes, the gender seems to play a role when I am seeking the association between gender and marks in this example. So, we stop here. What we have seen in this week is understand about association between variables. We looked at association between categorical variables, we looked at association between numerical variables, and we looked at association between a numerical and a categorical variable. Here we just restricted our attention to a categorical variable which has only 2 categories, and we introduced what is called the point biserial correlation coefficient.